All right, I'm Tyler Draper, and this is our Math for Teachers 1. We each have 6 homework problems, and I'm joined by.
Gabriella Guest.
And Sarah Renig.
All right, and this is my first problem.
So, Tyler, which factor tree for 168 is correct?
All right, so first we need to know what a factor is. So, a factor is a number or quantity that is, when multiplied, it produces a given number or expression. So, for instance, 2 times 2 equals 4. 2 and 2 would be a factor. A factor tree, that's a tool we use to break down the factors. And when we break down the factors all the way, we get prime factors, which are numbers that cannot be divided down any further. So this first one here, we have 168. We have 12 times 21 equals 168. That's wrong. So this far left one is wrong. 8 times 25. That one's wrong because that doesn't equal 168. On the right here, on the top or bottom right, we have 168 equal, or 8 times 21. That does equal 168. The only problem is the 4 at the bottom hasn't been broken down all the way. So the top right equation is correct. Our prime numbers are going to be 2 to the third power times 3 times 7. So the top right equation or factor tree is correct. Go into depth on, or Gabby, go into depth on how to solve this.
So what you do is you get your equation at the top, and it's 8,550 plus 6,888 plus 2,525 plus 6,029, and they're saying that it should equal 2,300,892. To check this, you break apart every single individual number. So to start off with 8,550, you put 8 plus 5 plus 5 plus 0, and that equals 18. And since it's a two-digit number, then you would break it apart and you get 1 and 8. So you would work your way down through all of these numbers, and you get 6 plus 8 plus 8 equals 30 to represent 6,888, and keep going down. And we know that since 6 and 7 are not the same, that is not correct, and the actual answer would be 23,992.
All right.
How does the divisibility rule of 3 differ from 2?
Okay, well, the first thing is 3 and 2, one's odd, one's even. So that's a big difference. And with the threes, what we're going to do is you're going to take the number and you're going to add each digit in the number together. So for 684, we're going to take 6 plus 8 plus 4 equals 18. 18 divided by 3 is 6, so it is divisible by 3. And I'm just going to skip down a few to the last one. So this is a pretty big number, and to figure out if it's divisible by 3, we're just going to break it apart. And I left the zeros out of mine, so it's 5 plus 2 plus 5 plus 5 plus 2 plus 8 equals 27. 27 is divisible by 3. It gives us 9, so it would be a yes. Now for the 2's, you look at the last number and see if it is even. 684, the 4 is even, so we know that 2 would divide that number evenly, because 4 divided by 2 is 2. If you go down to 51,051, we see the last number is a 1. 1 divided by 2 is 0.5, so that would be a no.
All right.
All right, Tyler, in the diagram, determine numbers to place in the red circles. So the sum of the numbers in each pair of adjacent red circles is the number in the corresponding large blue circle.
All right. So in this equation, basically what we're doing is we're trying to determine the red circles by making equations for the blue ones. So for instance, A and B will equal the 5. So A plus B equals 5. A plus C equals -6. B plus C equals -1. The first thing we need to do is add the first and second one. So we have a plus b equals 5 plus a plus c equals plus -6. It's important when we add and subtract these equations that we leave them in there, or that we put them in brackets when we change the symbols. Then we get 2a plus b plus c equals -1. Then we're going to subtract the third equation from the one we just got. And all in all, we end up determining that a equals 0. And once we find a, we can then plug the 0 into the equations that we already had. So 0 plus b equals 5. That means b equals 5. And now that we found b, we can plug b into this, and we determine that c is -6. And when we check our equation, 0 plus 5 equals 5. 5 plus -6 is -1. 0 plus -6 is -6. And we have a successful equation or diagram. Explain this example and also explain how you can measure a 5-rod.
Okay, so in this one, this just represents the original question, which it says which rods will measure 9 rod, and 3 times 3 would give you 9, and then you'd have 1 times 9. So you just put your rods with your 3s, your 1s, and your 9s. Now to explain how you could measure a 5 rod, you would think of multiples that go into 5. So 1 times 5, so you'd have a 1 rod and a 5 rod, and that would be it because 2 cannot go into it, 3 cannot, and yeah, that is how you explain that example. How do you know if a number can be divisible by 11?
Okay, to figure this out, it's not as easy as just looking at it like a 2 and see, oh, if it's even or odd. So what we have to do is you take the numbers and the place values, the odds and the evens, and we're going to add them together. So how you figure out if a number is in an even or an odd place value is you start on the right and you go towards the left. So the 4 would be 1, 8 would be 2, and 6 would be 3. So we have odd, even, odd. So what we do then is we take 6 plus 4 equals 10. We only have one even number. We have the 8. And you always want to subtract the smaller number from the larger number because you don't want to get a negative number. So 10 minus 8 is 2, and we can tell that that will not be divisible by 11. If we go down to, let's go down to 644,490. When we break that apart, we get 19 and 8. So when we subtract them, we get 11. So we know that 11 will be divisible in that number. If we go 1 up to 51,051, we see that the odd digits are a 0, 1, and 5, which gives us 6. Our even digits are 5 and a 1, which gives us 6 also. When we take them and subtract them, we get a 0. 11 is the only number besides a 5 or a 10 that can be divisible when you get a 0. So when we have the 0, we know that this number is divisible by 11 also. Okay, if the sum of the gray circles equals the blue circle, then what is the value of D?
All right, so in this equation, we know that the sum of the gray circles equal the value in the blue one. So, for instance, we have 5 plus a equals 9, so that means that a would equal 4. So to determine D, it's a process. We see that 5 plus 5, that means E would equal 10, and then 5 plus D would equal 8. So if we do our algebraic equation correct, we see that D would equal 3, and as we find one circle, we soon are able to find the next through algebraic steps. Could 4 be an even multiple in the 6-rod example? Explain why.
Okay, so at the original example, they wanted to see which rods to measure. 6 rod, which would be 1 and 6, and then 2, because 2 times 3 gets you 6, and then 3, because 3 times 2 gets you 6. So they want to know if 4 could also be into this example, and it could not, because let's say 4 times 1, that gives you 4. 4 times 2 gives you 8. That does not give you 6. And it just cannot go into 6 evenly at all. So no, 4 cannot be a multiple in the 6 rod example. When you use the process of casting out nines, why is the answer for A wrong?
Okay, so when we cast out nines, what we're going to do is break the number apart to see what we would get to check our answer. So we do 416 gives us 4 plus 1 plus 6 equals 11. And this is where we take our knowledge of casting out nines, because we want the answer to be less than 9. And 11 is more than 9. So what we do then is take 11 and break it into 1 plus 1 equals 2. 7,490, same thing. We're going to add each digit together, which gives us 11. It's more than 9, so we're going to do 1 plus 1 equals 2. 69,844, break that apart, it will give us 22. Obviously, that's more than 9. Break it apart to 2 plus 2 equals 4. All right, so now here's what we're going to do. We have all these sums. What we're going to do now is add them together. So 2 plus 2 plus 4 gives us 8. With this number, we can check the answer that we were given. So we take our answer, we break it apart. Now, as you can see, I have a 2, 7, and 9 crossed out. And that is because a 9 is a 9, and we're casting them out, so we don't need it. 2 plus 7 gives us 9, so we can cross both of those out. Leaves us with 1 plus 1 is 2. 2 and 8 are not the same, so this answer is a false statement. The correct answer should be 77,750. Okay, is the arrow representing a negative or a positive integer? And what is an integer?
All right, so we know that an integer is a whole number, and so that means it is a number that is not a fraction. And we see that we have the number line right here. So we have positive or negative integers. Negative would mean that the arrow is moving towards the left. Positive would mean that the integer is moving to the right. So as we can see in this equation, the arrow is moving from -2 to 2. So in this equation, we have a positive integer, and that integer is 2. What would the LCD of this example be? Use parts A and B to show GCD of 9 and 6.
Okay, so for the GCD of 9 and 6, it would just be 3 and 3, because it's just the smallest number that can go into both. 3 times 2 would give you 6, and then 3 times 3 would give you 9. So to find the least common divisor, you would think of the smallest number that both 6 and 9 can go into evenly. So we know that 9 times 2 gives you 18, so that's just the first number you think of with your 9. And you have to see if 6 could also go into 18. And we know that 6 times 3 gives you 18, so that just gives you the answer that 18 is the LCD of this example. What rods can we use to measure the 9-rod train?
To figure out which ones we can use, you can also think of it as what factors can we find that will go into 9. So we know the factors of 9 are 1, 3, 9, and that's really it. So the rods that we have listed, we have a 1, 3, and 9. So we can use those because 1 is a factor of 9. 9 is obviously a factor of 9 because 1 times 9 gives us 9. And 3 is a factor of 9 because 3 times 3 is 9. Okay, how many more revolutions will the small gear have to make before A and B are again in the same position?
All right, so first we need to determine what LCM is. So LCM is the least common multiple. That's the lowest quantity that is a multiple of 2 or more given quantities. So our two given quantities are 108 and 48. And to determine the LCM, we can do it one or two ways. We can do it the easy way, or we can do it the hard way. The easy way is the first step that I've drawn out here. We have the complete factorization of 48 and 108. 48 is 2 to the 4th times 3, and 108 is 2 to the 2nd times 3 to the 3rd. And what we do is we take each digit with the highest exponent and multiply them together. So 2 to the 4th and 3 to the 3rd would be 432. That gets us our least common multiple. Or we can do it the old-fashioned writing out factors way. And as you can tell, that's going to take a while, and you get 432. Since we're searching for the least common multiple, we need to divide 432 by 48, and we get 9. So that means the small gear will have to make 9 more revolutions before A and B meet back up at that same point. Explain an easy method to find the answer in this problem. Show all rods of trains to measure 18.
Okay, so the easiest method to me, I think, is just finding all multiples that go into 18 evenly. And you start off at the beginning. So 1 and 18, and that would give you 18, because 1 times 18 gives you 18. So you'd put your 1 cube and your 18s. Then you'd start with 2. And we know that 2 goes into 18 9 times evenly. So you have your 2 right here and your 9. You'd keep on going down the list to see how many other combinations of numbers. So you'd have 3 and 6 and 3. And that's just how you find an easy method to get the measurement of 18 with the rods. How do you solve a magic square?
Okay, to solve the magic square, we first need to find what our magic sum will be. And to find the magic sum is you take all the numbers and you're going to add them together. And you can see the numbers that we were given, they have mainly all negative numbers. So make sure when you add them that you do get you carry that negative sign with it, because you're going to get a total of 28, and then it's going to be a negative, and then with that positive one, we'll make it a negative 27. So after that, you can see we have each row and column contains 3 squares. So we can take the negative 27, divide it by 3, and that gives us a negative 9. So we know that the sum of each of our square, either vertically, diagonally, or horizontally, is going to be negative 9. And we have a 0 and 1 that was already given to us. So that's going to help a lot on trying to, figure out what our missing squares are. And another easy way to figure out what that middle square was or is to take your negative 9, divide it by 3, which will give us a negative 3. And that gives you a lot to work with, because now we have 3 squares that are filled in. And from there, you just put numbers in and check your work and make sure that you get all sums to be a negative 9.
All right.
Is 3,627 divisible by 9?
All right, so we need to look at our divisibility rules. Number 9 reads, sum of digits must be divisible by 9. We know sum means to add everything up. Divisor means to divide. Digits are any numeral from 0 to 9. So we'll add them up. 3 plus 6 plus 2 plus 7 equals 18. 18 divided by 9 equals 2. So 3,627 is divisible by 9. I may not know what it equals, but we know by these rules that it is divisible by 9. How did you solve this, and what was your method?
Okay, so just like Sarah said, she had a different kind of method, and she added up all of the numbers, and then she divided by the amount of rows. But what I did, which was kind of harder, I just did trial and error until I got all equal numbers all the way down. So you'd have 0, -7, and -2, and that would give you -9. And then you'd get -5, -3, and -1, and that would also give you -9. And then you'd have -4, +1, and -6. So I used trial and error, and that was my method.
All right.
How do you find the LCM of 40, 12, 44, and 363?
Okay, so when we're trying to find the least common multiple of these four numbers, we just make a little table like this. We put our 40, 12, 44, 363 on the top, and you want to leave that left column blank. Mine's filled in because I already did this for you, but I will walk you through it. So what you want to do is you want to start out with the lowest prime number that will be divisible by your numbers. So 2 is the lowest prime number that we have here. So we do 2 divided by, or 40 divided by 2 is 20, 12 divided by 2 is 6, 44 divided by 2 is 22, 363 cannot be divided by 2, so you just carry that number down. Anytime that you have a number that is not divisible by the number that you are using, you just go ahead and carry that number straight down. So then we just continue on. 20 divided by 2 is 10, 6 divided by 2 is 3, 22 divided by 2 is 11, and again we carry down the 363. At this point, you can see that, let me see where we're at. We're on the 10. So 10 divided by 2 is 5. And that's the only number that we can use the 2 on, so we just carry the rest of the numbers down. And then what I do is I just keep with that the left column until I am all the way done with it and I have a 1. That way I kind of keep it organized and I can keep track of where I'm at. So now I use a 5. 5 divided by 5 is 1. It does not go into anything else, so you just carry the numbers down. The next one is 3. So now we have 3 divided by 3 is 1. Our first 2 have 1s in them, so that's great. 11 is not divided by 3, so we carry the 11 down. 363, it does divide by 3 to 121. So now we want to get rid of the 11. So 11 divided by 11 is 1. 121 divided by 11 is 11. And again, we put another 11 on the left column, and 11 divided by 11 is 1. So the answer to what is our LCM would be 2 cubed times 5 times 3 times 11. And how we get that is you look on the left column and you add like what we have. So we have 3, 2, so that's what gives us a 3 cubed. And that's how you find your LCM.
All right, and that is our 6 math problems. Thank y'all for tuning in.